All right, guys, this is section 4.4 titled, well, I can scroll up there, Graphing Linear Equations in Slope-Intercept Form. It's one of our most important sections because we're talking about slope-intercept form, which is a huge topic in pre-algebra this year. And so we're going to talk about a couple different things. We'll talk about what intercepts are and how to find intercepts. And then we'll talk about how to graph equations without having to use tables like we did in section 4.1, where we had to plug in a value for X and then get a value for Y and then use those values. And that using a table like that's great when you have a nonlinear equation, but if we have a linear equation, writing our equations in slope-intercept form is very useful for graphing because we can do it without having a table. It's very simple. So I'll show you how to do that. So let's start off by talking about intercepts. The x-intercept of a line is the x-coordinate of the point where the line crosses the x-axis. It occurs when y equals 0. Okay, so think about that for a second. If it's an x-intercept, intercept is kind of close to the word intersect. And so the x-intercept is the point where the line crosses the x-axis. Okay, and so it always occurs when y equals 0. Now, why not when x equals 0? Well, on the x-axis, if I can scroll here, on the x-axis, which is right here, regardless of whether I've got a negative x-coordinate, I'm on the left side, or if I've got a positive x-coordinate, I'm on the right side, my y value on the x-axis is always the same. Because I have not gone up or down any, the y value is always 0. So if I'm on the x-axis, y always equals 0. That's very important to know. Now, the y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. It occurs when x equals 0. So the y-intercept would be this point right here, where even though I can go up and down on the y-axis, because I'm on the y-axis, I haven't gone left or right any. And so my x value is always 0. So on the y-intercept, the x value is always 0. And on the x-intercept, the y value is always 0. That's something good to know. And so again, it's where the line crosses the y-axis, where it intersect. Think of the word interception like in football, where a player crosses the path of the football and picks it off, right? That's that same idea here. Where does it cross the x-axis, or for y-intercept, where does it cross the y-axis? So you can graph a linear equation by finding the x and y-intercepts. This still isn't the way I'm going to show you, but this is actually a pretty interesting way that you can graph a line, and something you're going to need to know for your next quiz. See if anything I put up there. There we go. Graph each linear equation by using the intercepts. Okay, so remember, it only takes 2 points to graph a line. Well, instead of plugging in random values for x and getting y's, which I could do, the 2 points I'm going to use, x-intercept and y-intercept. Those only takes 2 points to graph a line, so those are the only 2 points I need. Now, to find the x-intercept, remember, I know that no matter where I am on the x-axis, the y value is always 0. So I can plug in 0 for y. Now, remember, I told you 0 is always one of the easiest numbers you can plug in, and we're going to plug it in for y here. So if I plug in 0 for y, 3 times 0 is just 0. So I'm left with negative 2x equals 12. Divide by negative 2, and that means x is negative 6. So the point that I'm going to use here, if x is negative 6 and y is 0, is the point negative 6, 0. And that's going to put us right here. That's my x-intercept. Okay. Now, for the y-intercept, what do I know about the y-intercept? Well, if I'm on the y-axis, the x-coordinate is always 0. So I'm going to do the same thing, except this time I'm going to plug 0 in for x, which again, plugging in 0 is super easy. So if I plug in 0 for x, negative 2 times 0 is 0. That goes away. And that's going to leave me with 3y equals 12, which means my y value, when I plug in 0, is going to be 4. And so the point I'm going to graph is when x is 0, y is 4. And so the y-intercept is up here at 0, 4. And then I simply draw the line that intersects through both those points, all the way through my graph. My line has to have 2 arrows, needs to go all the way through my graph, course, if I'm doing this on big ideas, I don't need to show my graph on my work paper, but I am going to show the work that I'm doing to find my X and Y intercept on my work paper. All right, let's look at the next one. The equation is 8x minus 12y equals negative 24. Now remember, when we were solving these last couple sections ago, I had you solve this equation for y because it'd be easier to plug in numbers for x that way. And so we're still plugging in numbers. I'm just not having you solve it for y. So if I want to know what the x-intercept is, I just plug in 0 for y. And if I want to know what the y-intercept is, I just plug in 0 for x. And I don't need to rewrite the equation at all. I just solve. I just plug in and solve. And so that's what I'm going to do here. If I want to know the x-intercept, I need to plug in 0 for y. And if I plug in 0 for y, negative 12 times y is just 0. So I'm left with 8x equals negative 24. And then I can divide by 8 and get x to be negative 3. So when I plug in 0 for y, I get negative 3 for x. So that would actually be the point that I'm going to graph. Negative 3, 0 is right there. And then for my y-intercept, this time I'm going to plug in 0 for x because on the y-axis I haven't moved left or right at all. So I know the x-coordinate is always 0. Any of these points, right? Any of these points, my x-coordinate is always 0. And so that's why I'm plugging in 0 for x because I know that's always true. And so that's going to give me 8 times 0, which is just 0. And then negative 12y equals negative 24. And they're giving us some really nice numbers to work with. Y is going to equal positive 2. So when I plug in 0 for x, I get 2 for y. So my y-intercept is 0, 2, which is right here. And then my line needs to go all the way through my graph with 2 arrows, just like that. Okay, so very simple to do. Using the intercepts is an easy way to graph a line if the equation is written in standard form. Okay. A lot of times when you work with equations, you get an equation that's written in standard form, and standard form is ax plus by equals c. Whoops, my lights just went off. And so remember, we had a whole section in our equations chapter where we were taking equations that were written in this form and then solving them for y, getting y by. So we had to move the x value over to the other side. We had to divide to get rid of the coefficient with the y term, which in this case would be the b. So a, b, and c are just numbers here. Don't freak out by all the letters. A, b, and c are just numbers. And so we'll talk more about standard form later here. But for right now, I want to show you what slope-intercept form is. So again, if I have a line that's in standard form, it's really easy to graph using the intercepts. But if I have a line that's written like this, which by the way, a lot of our line equations will be written like this that are already solved for y, this is called slope-intercept form. And this is why we spent all that time solving our literal equations for y and moving the x value over and doing all that, because this is called slope-intercept form. Y equals mx plus b, where m is the slope of your line and b is your y-intercept, where it crosses the y-axis. And so you will need to memorize this formula. It's not very difficult, and an easy way to do it, if I can get my lights to turn on here, an easy way to remember it, and it's kind of cheesy, but it's y mx b, which if I was standing up in front of you, I would make a little teapot B thing, but kind of like YMCA, but y equals mx plus b, ymxb. So we have to remember those letters and what they stand for. Y and x are always in every single equation. I always leave the y and x alone, but the m and b stand for something significant here. The slope is the m value and the b is the y-intercept. That's why I tried to be consistent with my dark purple that I use for all the y-intercepts here. Okay, so that every time you see this, you can think, okay, that's my y-intercept. So before we do anything when it comes to graphing, let's, with our training wheels on right now, figure out if we can determine which is our slope and which is our y-intercept. So this equation is written in slope-intercept form, which means the x coefficient is my slope. In this case, my slope is -4. Do not tell me that the slope is -4x. I don't care about the x. I just want the m value, the coefficient. So -4 is our slope. And then our y value, or y-intercept value, you can see that this equation originally had a plus. Well, what would have changed it from a plus to a minus? A negative number would have done that. So don't put 2, but put -2 as your y-intercept value. So our slope is -4, our y-intercept is -2. In this example, our slope is 3/4. Remember, slope is rise over runs. We're used to seeing it as a fraction. And our y-intercept is -7. Now, this one, they're trying to throw you a curveball already. This is not in slope-intercept form. Slope-intercept form is y equals mx plus b, and this equation is not solved for y. So I just need to add 5 to both sides. And then I have y equals 3/2 x plus 5. Remember how I always said write your x variable in front of that constant? That's because it's y equals mx plus b, not y equals b plus mx. And so I want to put that x variable first, which means my slope is 3/2, and it crosses the y-axis at 5. And last one here, this is definitely not in slope-intercept form. In fact, this is in standard form. ax plus by equals c. This is standard form. This is what standard form looks like. And so I'm just going to simply solve this for y by subtracting x on both sides and getting 2y equals, put the x value first, -x minus 6, and then divide everything by 2. I'll write it over here. Y equals, there's no number in front of the x, so let's just assume that's a 1. -1/2 x. And then -6 divided by 2 is -3. Okay, since slope is rise over run, I probably wouldn't write my slope as a decimal if I can avoid it. I just go ahead and leave this as -1/2 as our slope, and then -3 for our y-intercept. So remember, you only need 2 points to graph a line. So how is this helpful? Well, if I have an equation that's written in slope-intercept form, the y-intercept is a point on my line, and then I can use the slope as the directions to the other point. So very easy to graph equations that are in slope-intercept form. In fact, way easier than plugging in numbers. Because plugging in numbers, even if it's as simple as plugging in 0, like we did when they were in standard form and we were graphing the intercepts, plugging in numbers always takes math, right? You have to count, you have to multiply in your head, you have to subtract, add in your head, right? We don't have to do any work in our head here. As long as the equation is in slope-intercept form, I don't need to do any work here. I know that my y-intercept, my b value, is 3. So I go right up to the y-axis on 3. No work required. And then I know my slope is also 3. Now, that means I'm going to do my rise over run. Now, 3 is not a fraction. I can easily turn it into a fraction by putting it over 1. And I'm going to rise 3, 1, 2, 3, over 1. And I'm going to put another dot right there. And then my line is going to look like this. That took no calculations on my part. And another thing you can do is, instead of going up 3 over 1, you could actually go down 3 over 1 to make sure your line is in the right spot. And so you can see all these points should still be on my line. If I graphed it right, it should be straight, right? And so my slope is constant. So I don't have to do any work there. I just need those 2 points and I draw my line. So my x-intercept, for some reason on your homework tonight, they're going to ask you for the x-intercept like every time you graph, which I'm not sure why they do that. But either way, you can see because I'm going down 3 over 1, my x-intercept, where it crosses the x-axis, is right there at x equals -1. Or if you want to write it as a point, -1, 0 is my x-intercept. Okay, so really easy to graph in slope-intercept form. Let's do another example. Okay, I've got my y-intercept. I always start with that because I need a starting point, right? My y-intercept is -2, which tells me this line crosses the y-axis at -2, which is right there. That's my b value. And then my slope, my m value, is always my coefficient with the x variable, which is 2/3, which means I'm going to rise 2 and run 3. And I can rise 2 and run 3, or I can go down 2 and left 3, and that point should also be on my line. Let's make it a little bit straighter. Make sure you draw your arrows. Should be right there. There we go. And that's my line. I don't think that line's as straight as I'd like it to be, but it's close enough. And so you can see it crosses the x-axis right here at x equals 3. Or you could say 3, 0. Okay. So simple enough. Again, a lot easier than plugging in numbers, which, by the way, I could still plug in numbers. You could plug in 0 for x. If you plug in 0 for x, 2/3 times 0 is 0, minus 2 is -2. So when I plug in 0 for x, I get -2 for y. And guess what? 0, -2 is on my line. My y, that's literally my y-intercept is on my line. And then what's another easy one? I probably wouldn't plug in 1 because 2/3 times 1 is 2/3. Maybe plug in 3. If I plug in 3 for x, 2/3 of 3 is 2, minus 2 is 0. And guess what? 3, 0 is also on my line. So this is way easier than plugging in numbers. Even if I can do it in my head, I don't have to do anything in my head. I just literally put a point, graph a point, and then count, rise, over, run, and get my answer. Now, if they give you an equation that's not in slope-intercept form, I must convert it to slope-intercept form. So here I would need to add 4/3 x to both sides because I want y by itself. So this would give me y equals 4/3 x minus 4. Now it's in slope-intercept form. And so my y-intercept is -4. My slope is rise 4, 1, 2, 3, 4, run 3, 1, 2, 3. I could also go the other direction. It would just take me off my graph. 1, 2, 3, 4, 1, 2, 3, somewhere down there, right? So if it takes me off my graph, I probably don't want to use it. Okay, there's my line. Get rid of all that stuff there. Okay. And again, I could even rise another 4 and run another 3. And guess what? Right there, I'm still on my line. So you can use the slope as many times as you want. If I'm taking a quiz on paper pencil, I usually will use the slope all the way through my graph just to make sure my line's as straight as possible. So what do I mean by that? Well, once I graph those, I go up another 4 and over another 3. And now I can make sure my line is very straight when I'm using paper and pencil. That way I don't need a ruler. I can just kind of connect those and make sure it's as straight as possible. So this is another very easy one to tell what your x-intercept is. Your x-intercept would be where it crosses the x-axis. Of course, we know it crosses the y-axis at -4. That was part of our slope-intercept equation. But the x-axis or the x-intercept here is going to be at 3, or you can say 3, 0. That's the actual point that it is. And let's look at this one. This one's in standard form, so I could use the intercepts, but I want to use slope-intercept form for this. I don't want to use the intercepts. I want to use slope-intercept form to graph these. So I'm going to add 3x to both sides. In fact, you don't have to show that work on your paper. You do need to show your work converting, but you don't need to write that you're adding 3x to both sides. That's going to give me 3y equals positive 3x plus 6. So I had to add 3x to both sides, and then divide everything by 3 to get y equals x plus 2. And so my y-intercept is obviously 2. So I'm going to start right there on the y-axis. And then my slope, there isn't a number there. There is, it's just we didn't write it. It's a 1. So my slope is 1, which is 1 over 1, which means I'm going to rise 1, run 1, and I can literally put all those dots. This is a really easy one to graph on using Notability. And then I'm going to go down 1 to the down 1, and then go down 1 and then 1 to the left. Would be the same thing. So there's my line. You can see it crosses the x-axis right here at -2, which would be -2, 0. All right, one more, just in case. And so here we're going to solve for y by subtracting 5x from both sides. I'm going to put that minus 5x in front of the -6. And then divide everything by 2, every term by 2. So y equals -5 divided by 2. Write it as a fraction because I'm using slope here. That's just -5 halves. I'm dividing by 2, and since 2 doesn't go into 5, just write it as -5/2 x, and then -6 divided by 2 is -3. So my y-intercept is, whoop, that's +3. Let's move you down. My y-intercept is right there at -3. And then my slope is -5/2. Now be careful here. If I go down 5 and then go right 2, which I could do, it just takes me off my graph. So instead of going down and then to the right, let's go up 5 to the left 2. And it's going to give you the same line, but I'm able to use that point because big idea is not going to let you go off the graph there. So you're just going to have to flip around the direction, or the traveling that you're doing. Instead of going down to the right, go up and to the left. It's still negatively sloped, because remember, negative slopes go downhill from left to right. So we know this is still a negative slope. Now here's our issue. And this is going to happen a lot on tonight's homework. So please don't bombard me with emails. Just pay attention right here. Okay. That's not a very nice x-intercept. And you can try guessing all you want on that. Okay. I don't know why, but for some reason they give you several problems on tonight's homework where they ask you to find the x-intercept, and it does not give you a very nice answer. Okay. So what do I do? Well, I know it's between -1 and -2, but I need to know an exact number. So I'm going to go all the way back up to where I said more on this later. Every time that we had an equation that was in standard form and we wanted to find the x-intercept, what did we do? We plugged in y = 0. Okay, so that's what I'm going to do. My equation's not in standard form. It's in slope-intercept form, but I'm still going to plug in y = 0. Okay, and I'm going to solve for x, and whatever x is, that's my x-intercept. So I would add 3 to both sides. And then I would divide by -5/2, which dividing by -5/2 is the same as multiplying by its reciprocal, -2/5. So I'm going to multiply both sides by -2/5. So 3/1 times -2/5 gives me -6/5. So x equals -6/5, or you could say -6/5, comma 0, because we plugged in 0 for y. We always know the x-intercept, the y value, is 0. So you're going to have a couple problems like this where you have to do some math, right? Which is what our work papers are for. And so I know that makes sense, because if I write this as a mixed number, -6/5 is -1 1/5. And you know what? It's pretty close. -1 1/5, that's pretty close right there. So that's how I solve it. What did I do again? I plugged in 0 for y, and that gave me my answer for x. Okay, that's how I find the x-intercept. Plug in 0 for y, solve for x, and you'll get -6/5 or -1 1/5. Okay, so you'll have a couple like that in your homework. Make sure you give the correct x value for the x-intercept. All right, next up, we got this taxi problem. The cost y in dollars of taking a taxi for x miles is 2.5x plus 2. Graph the equation and interpret the slope in y-intercept. So the y-intercept is going to be 2. You can see they're only using quadrant 1 of the coordinate plane. That's because you can't have negative miles. You can't travel for negative miles in a taxi. You can't pay $dollars in a taxi. So we don't need any of the negative numbers. So the all positive quadrant 1. And then I'm going to rise 2.5 and run 1. Now I could rise 2.5 and run 1, and that's fairly accurate, right? Or isn't 2.5 the same as 5/2? Right? You could just write it as a improper fraction and then go up 5. 1, 2, 3, 4, 5 over 2. Okay, and then if I would have gone up 2.5 over 1, you can see, yeah, about the same spot, right? Okay, so could do either way. There's my graph. Interpret the slope and the y-intercept. So the slope, because slope is a unit rate, a rate of change, we can actually look at it and we can say, since slope is the rise over the run, that's the change in y over the change in x. The y-axis is the dollars axis. And so my slope would be $2.50 for every 1 mile. So my slope is $2.50 per mile. So my slope is literally the unit rate of this problem, $2.50 per mile. That's what X stood for anyways, right? That's why the 2.5 is right there with the X value, okay? Or I could say 5/2, but that's $5 for every 2 miles, and that's not a unit rate. I'd want to reduce that. I'd want to divide that, I should say, and get $2.50 per mile. Okay, and then the y-intercept is 2, and that's the value you pay. You can see even if I travel 0 miles, I automatically start here at 2. That's the value I'm going to pay no matter what. As soon as that taxi pulls over and I get in, I'm already paying $2. Whether he takes me anywhere or not, he's already pulled over for me. He's lost customers. I have to pay $2. That's my initial fee of $2. Okay, so this equation does not go through the origin. It starts $2 above the origin because that's how much we're paying, even though we're starting. We call that the initial value. That's how much you pay before you even start adding on the miles to your trip. The cost Y of taking an Uber is 2x plus 1.5. Graph that equation and interpret its slope and y-intercept. Okay, so the red line here is our taxi. Let me get rid of this blue dot. Maybe not. Okay, the red line is our taxi. Let's use green for the Uber. And so it has a y-intercept of 1.5. Close enough. So a cheaper initial value for this Uber. And it has a slope of 2. Well, it has a cheaper slope too, a cheaper unit rate. And so I'm going to rise 2, 1, 2, and then run 1. Because remember, I have to turn that into a fraction, 2/1 for my slope. And so this green line represents the Uber. Now those lines look pretty close to parallel, but they are not. One line has a slope of 2. The other line has a slope of 2.5. So not only am I paying more to get in the taxi, I'm paying more per mile. I've got a cheaper initial value for the Uber and a cheaper slope unit rate for the Uber. And so Uber is always going to be cheaper, according to this problem, than what a taxi would, which is probably true in real life too. That's why it's made Uber and Lyft have gotten so popular. And so the Uber's unit rate we said was $2 per mile, and its initial fee was $1.50. Just to pick you up, just $1.50 just to pull over for you. And then probably my favorite problem we're going to do all year. I am a huge movie fan, and this quarantine and COVID that we've been going through has made it very difficult for me to do that. But we are a fan of AMC, and we always buy the popcorn buckets. I don't know if any of you guys buy the popcorn buckets or not. It says you buy a large bag of popcorn each time you go to the movies. The cost of a large bag of popcorn at the Kokomo AMC theater is about $10, which is true. The annual AMC popcorn bucket costs $25, or if you're a Stubbs member, it costs $20. At least that's what the price was last year. And $5 to refill it every time you go. How many trips, X number of trips, to the movies would you need to take in order for the popcorn bucket to be worth the price Y? So at what point is it actually more valuable or cheaper, I should say, for us to just purchase the bucket? How many times would I have to go for the bucket to pay off? Right? That's a good problem. You can take this home to your parents and show them, see, Mom, we should get the bucket now. So we need 2 equations because we have to graph 2 different things. The first one here, it says the cost of a large bag of popcorn is about $10. So since Y is the price, my first equation is going to be Y equals $10, but I'm paying $10 every time I go because it says you buy a large bag of popcorn every time I go. And so those are called trips. And so $10 for every trip. There's my first equation. So if I buy a large bag of popcorn, I'm paying $10 for every trip. Now the popcorn bucket only costs you $5 a trip, but you have to buy the bucket. And so it's going to cost you $5 for a trip, but you're going to have to pay $25 just to buy the bucket. So add another $25. Again, that's our initial fee, our initial cost, $25. And then, so it's cheaper to use the bucket, but it's more expensive to buy the bucket. So how many trips would I have to take in order for this to pay off? Let's go ahead and graph and find out. Okay. So my y-intercept, you're going to notice here on my first equation, I don't have one. And so I do have one. It's just 0 because I don't have to pay any initial fee for my large bag of popcorn I buy every single time. So I'm going to start here at 0. That's my B value. And then I'm going to rise 10 and run 1, which is the same as rising 20 and running 2, since I counted by 2s here. So this line here, that line right there, this represents my large bag. Okay. So obviously the more I go, the more I pay. That's pretty obvious. The purple line. Now we're already going to be starting here at $25. That's my y-intercept. But I only have to pay $5 to refill it. So rise 5, run 1, or rise 10 and run 2 would be the same thing since I'm counting by 2s. And so we've got, this is the popcorn bucket. We've got what they call an equilibrium point. Okay, an equilibrium point. That's the point where it actually doesn't matter which way I go, right? The bag and the bucket cost the exact same. So let's see if we can figure out what this equilibrium point is. If I can draw a straight line, straight down, it looks like it would be, what, 4 times? Be 4 times, and it would be the exact same. But I'm not quite sure on that. So I'm going to have us do one extra step. I'm going to have us solve. So I have 2 equations, y equals 10x and y equals 5x plus 25. And in order to find the equilibrium point, I'm going to do what I did in my chapter 1. I'm going to set those 2 equations equal to each other. So 10x, $10 for each bag of popcorn for every trip I go is going to get me a large bag of popcorn. I'm going to set that equal to the $5 I pay for a trip for the popcorn bucket plus the $25 fee. X is going to be the number of trips for this to be equal. And so subtract 25. I'm sorry, don't subtract 25. Subtract 5x first because you want to move the variable to the other side. And you're going to get 5x equals 25. And then x equals 5. So my graph was not very accurate, was it? What did I do wrong here? Rise, let's see, start at 25. It went up 5 over 1, up 10 over 2. So the purple line looks good. My red line, started at 0. I rose 10 and ran 1 or 20. So basically, just because my graph is a little inaccurate, it should have been closer to there. It should have been equilibrium point about right. Well, let me erase all this. My equilibrium point should have been somewhere in this area. So I wasn't too far off, but I was far enough that graphing is just a little bit inaccurate, which kind of proves my point that algebra always gives you the answer without guessing. And so after 5 trips, the bucket pays for itself. So if you go to the movie theater more than 5 times a year, you should get the bucket. And I guess you can convince your parents of that. Now, if you don't go 5 times a year, you should probably stick just getting that large bag of popcorn each time. All right, that's it. Let me know if you guys have any questions, and I'll see you later.